Hi all, and welcome to this series of sessions on OOPS concepts or object-oriented programming concepts. In this series, we will start with the introduction topic, introduction to the object-oriented world. Now, whenever this object-oriented programming, object-oriented analysis and design, anything relevant to object-oriented as a pair of words comes into the reading or into the topic, obviously you will refer it to the image which you must have seen in academics or in any of the internet material or anywhere very quickly as this image, where animal is a class, then dog is a child class, cat is a child class, cow is a child class, and then we say dog barks, cat meows, hyena laughs, and so many other things. This is where typically a polymorphic behavior is taught and all those things are completed, and we say yes, this is what object-oriented world is, and we have understood object-oriented world, and blah blah blah, as is this is what will be the reaction of the listener to this session or the reading. So are we going to listen and understand the same thing? Maybe kind of, but there are lots of new things. And by listening to this, you must have confirmed that by now that this must be by some old teacher who has learned all these things 20 years back, and whatever was true 20 years back is no more true now. We are leading to the keywords like a Docker, AWS, machine learning and other things. And is there any relevance for this dog barks and cat meows? Why should we learn it? And what is going to be really a value addition? Is there any company who is going to pay us for writing this kind of programs where a dog barks and cat meows? Obviously not. But if you think that way, even for writing a programs which are going to write the formula for factorial or the string inversion, I'm sure no company will pay for that as well. So that is not the difference between this topic as such and the value addition, but it is at what level. That is what is a major value addition of this course. We are talking about an industry standard. And what we might have learned is more in the academics perspective, but industry standard actually aims at writing the robust programs, and that is what is going to be our focus. This topic as a OOPS concepts is a foundation, and this is not going to be a complete topic by itself. The topic is really vast. It goes up to the analysis and design, the design activity, and further the architecture. Now let us enter into the world and maybe cross-check some of the concepts which we talked about. Always it is said in the literature as well as everywhere in introduction to this topic that we perceive surrounding things as an object, or all the things as objects. Even the person whom we are meeting, the lamppost which we come across, maybe the vehicle which we come across, everything is perceived as an object. Now, the object around us, whenever we say, we always imagine the non-living things. And in the real world, there is a combination of living and non-living objects. Means the dog and cat in the earlier example was a living thing, whereas the shape or maybe the car, truck, scooter and vehicle, these are all non-living things. Now, even though this is the biological, say, categorization or grouping, that is not going to help us really, because in our real world now we see that there are certain non-living things, and those also can do their activities on their own, but otherwise the biological classification says that non-living things cannot do their things on their own. They cannot move, they cannot breathe, they cannot do lots of things, whereas living things can move on their own, living things can breathe, living things can grow. But that definition is not going to be helpful for us in understanding the object-oriented world. So that was the first confusion which created thing that dog barks and cat meows, is it going to help us in programs which we might be talking about or we might be writing for the Dockers, AWS, and machine learning and so many other advanced fields, or even in a simple case developing some website. Are they going to be really useful to us? Now let me give you one example, and that example will actually help us understand, even though these are non-living objects, we can treat them as autonomous agents, and I'll explain you what do I mean by autonomous agent. Take an example of anti-aircraft gun and a radar associated with it. Every machine is something in between the living and non-living things nowadays. So these machines are capable of doing certain things on their own internally once we give them the trigger. For example, if we start the vehicle, it can start and it can do certain things in sequence. A washing machine, after starting, it can do certain things on its own. Similarly, let's come back to our example and see how objects behave in the real world and how is it relevant for us in software object-oriented world. So in our example, this radar is continuously doing a surveillance task. That means it keeps on rotating in 360 degrees and it keeps on detecting whether it is getting any spot of the target on its screen. Once it detects, it quickly takes its coordinates like azimuth and elevation, and it is going to send a message to two things. One is the operator, second is to the gun combined with it or coupled with it. Now gun gets a message. In software world we call it as a message, in electronics world we will call it as a signal. So radar sends a signal to the gun. Now gun understands that there is a task for me. Gun also orients itself into the same coordinates as a radar. But whatever that calculation is there, we'll ignore it. But now gun starts rotating, keeping the same location as of the target. Now radar is also tracking the target. It is giving the message to the gun. Gun is also taking that message and orienting into the same angle of azimuth and elevation, and intermittently it is firing its rounds. You will observe here there are many objects. Topmost level there is an operator, the radar operator, radar, gun operator, the message between them. The radar has got many smaller objects in it, and we will not going to dissect it because that might create so many small objects inside it. But as far as the operator is concerned, operator knows only about a radar. As far as gun is concerned, gun knows only about a signal which it gets from the radar. Gun also has got lots of objects. In fact, the round itself is an object. The round is fired from the gun. Now all these objects, if you see, they have been given their tasks once the trigger is given. If the gun is given the signal that yes, I have found target with this azimuth and this elevation, gun will lock to it, those coordinates, and gun will start firing the rounds to its targets. Now you will observe, given a message, the object, one object is going to trigger another objects or send messages to other objects in sequence, and this complete world will work. So with the mechanization or industrialization, we have got few more objects around us which are really not living, but they almost behave like a living objects. And that is where our value addition really matters. And inside a software world, we are going to deal with more of the conceptual objects. Those are virtual objects. The mistake was that actually the real world objects and the mixing them up with the virtual objects. Yes, our question was, is there any company who will be willing to pay us for writing some stupid program like the animal is a base class, cat and dogs are the child classes, and for writing few statements like dog barks and cat meows? Will company really pay for us? Obviously not. But imagine the project on which you are working is for a game developer on the mobile or maybe anywhere. And that game is about the kids playing with the animals. And there might be some animated dogs, animated cats. And once the child clicks on it, it is going to make a sound. Now it looks relevant that company might pay you for writing program where dog and cat are going to be, dog is going to bark, cat is going to meow, hyena is going to laugh, and so many things. But remember, these are the counterparts of real world objects, living objects. These are counterparts in the software world object or software object oriented world, and they are conceptual or virtual counterparts of real world objects. There is going to be a specific term being used for this, which we'll learn down the line. It's called as an abstraction, but right now we'll not talk about it. That is where we call in this software virtual world that every object is an autonomous agent. Autonomous agent means once it's like the radar is given the, suppose someone presses the button, the operator presses the button of radar knows that I should start my work now. So radar will start rotating its antenna, surveillance antenna, and it will keep on detecting. Once the target is detected, it will give message to its tracking antenna. Now operator is no more in the picture. Now radar is taking on its own few actions. It is going to send a message to the tracking antenna. It is also going to send a message to the gun. It is going to send a message on the screen to the operator that yes, I have detected something. In this sense, the radar as an object, if we treat that as an autonomous agent, the radar will have its own functionality based on the logic to be triggered. And of course, it will have its own data or the objects inside it so that it can use that data or use those internal objects. Wherever the task to be worked out goes outside the scope of that object, it will send a message to the other object. In our case, the radar's job is not to fire the rounds, but radar's main task is to identify or locate the target. Now it will cooperate with the gun by sending a message, and it's a gun's task to fire the rounds. Now this is where the picture comes into our mind that objects collaborate with each other and they perform a higher level task. So bringing down the enemy aircraft was a higher level task, and the participants of this complete activity were the radar operator, maybe the gun operator, who is actually feeding the rounds in it or controlling some parameters, and the messaging between these objects. Now this makes sense now, and we will go into more depth and understand how these things happen. But I think this is going to be sufficient for us to get convinced that yes, this subject is really worth listening to. Now let us come down to the real context in which we are talking about all these things. We are really talking about the systems or the applications which are of a larger size, of a larger scope, like say railway ticket booking service, or it might be airline booking service. All these systems being complex in nature, there are certain properties associated with the complex systems. Even though we are not going to more details about complexity of the system as a topic, but at least try to understand the things which are going to come along with when we are talking about complex and industry standard systems. Complex systems are more vulnerable to break down. A simple system is less likely to break down compared to a complex system. This can be convinced very easily based on our common sense itself and does not require any further explanation. We are talking about systems which might be using really a very large volume of data. Whenever you make a call to some call center or somewhere, you sometimes get a message that this call is recorded for analysis purposes. Now what does that mean? There is going to be some repository where all the messages or the conversations is being stored, and such a huge volume of data some system is going to analyze. And it may happen that you will be working on those systems as well. Those are definitely a complex system because the data volume is so large. System itself might contain some intelligent decisions, and intelligence decisions, obviously, if you know something about a machine learning or the data science, we are talking about the decisions based on some volume of data, and those are not really outcome of some if-then-else statements. There might be a statistical elements involved in it, and that is where the complexity of the system is related to the intelligent decisions. If we look at all the challenges, then we can get easily convinced that the efforts required for developing such complex systems, they go beyond the individual intellect capacity limits. Now, based on all these inputs, as far as the complex systems are concerned, not a single person can say that yes, I will do it completely. And suppose someone is capable of doing it, will you get always such a team members for your project? First of all, how much expensive will it be if a single person is going to develop this all? So we are not going to depend on a single person, and that is why it is going to require a collaborative and coordinated efforts to develop such kind of a system, even to maintain such kind of a system, or even some enhancements. And that is where the collaborative world and a coordinated efforts is going to be a key for development in this field. So how do we do about it? System requirement is going to be a huge set of collection of requirements. Now to handle this, say imagine the railway reservation system or the bank operations as an online bank is going to contain lots of functionalities. A best way and a common sense based solution will be to split the functionality. Split the total into meaningful parts is the common solution which has worked in many of the other fields. In short, divide and rule. And that solves our problem. We can divide really a complex system into smaller parts, of course meaningful parts, and then rule the complete phase of development and maintenance, obviously even enhancements as well. The word which is being used in the field of software for splitting the system of total into smaller parts is known as a decomposition. Decomposition means consider a complete system, break it into smaller modules, classes, functionalities, functional units, procedures, files. All these are decomposed units. There are two dominant ways of decomposition used in the software field. The first one is of more importance to us, and it's called as object-oriented decomposition. Of course, the alternative one is the algorithmic or arithmetic decomposition. Both these methods of decomposition, namely object-oriented decomposition or algorithmic or arithmetic decomposition, they do have their own importance at appropriate places. So let us consider the object-oriented decomposition. So in this method of decomposition or splitting the total into meaningful parts, what we do is we distribute the functionality to autonomous agents called objects. We have seen in our example that autonomous agent or object means the thing or which can do its tasks on its own, which has got a data to perform those tasks along with it as a capsule, and which can send a message to others if it wants to get work done from some other object. Now this is where this autonomous agent is going to come into picture. So as far as the functionality is concerned, we are going to split it. The expected functionality will be split into objects and capsules associated with those objects. Now these individual objects are going to own their own set of data required for performing the tasks which they have been allocated. It is always said that the responsibilities and powers should go hand in hand. Similarly, in software, the responsibilities as the tasks which can be performed on that object and data which is required for completing that functionality should be along with the object. So object has got the authority to use that data and of course the functionality as a responsibility. This is going to be a smallest unit of object-oriented world. Now objects need not do everything on their own because they always believe in cooperation. Objects can send messages to each other and really get work done from others, otherwise decomposition will not be there. Especially in the college project, you will find most of the times there is only one class. Of course here object and class we will find out what is the difference between them. But in a so-called object-oriented program, we find only one class or at the max 2 or 3. This class is called as some XYZ manager, XYZ engine, data engine or something like this, and most of the logic is written in that class itself. What has happened here is, the mistake is decomposition has not happened because only one class is doing everything, and such a symptom is actually against the directions of object-oriented decomposition. Such a class is called as a God class, where God does everything, so this class does everything, but this gives an indication or a smell of a failed object-oriented decomposition. So that is one of the symptoms, but the focus here is that object-oriented decomposition gives us the individual units as objects, as a capsule. They do have their own data, they do have their own tasks to be performed on them. Now to send a message to each other, it's very important that objects do need their references in the pairs. Suppose object A wants to send a message to object B for doing certain tasks. Object A must have the reference of object B. Now this reference is something similar to mobile number. If I have got your mobile number, then I can call you, but you cannot call me because you do not have my mobile number. That's a very loose analogy, but the reference is something similar. So we have come to conclusion that after decomposition, what we get is we get the set of objects, each object with its own data, with its own responsibilities or the functionalities to be called on that object, and the relationships between those objects which must exist for objects to call upon each other's functionalities. Now this is what is called as object-oriented decomposition. The other alternative approach or other alternative method of decomposition is known as algorithmic or arithmetic decomposition. What we do in this is, whenever we decompose a complete functionality of the application or a set of expected functionalities from that application as a black box, we split them into functional units, meaning the functionalities are split as the procedures, functions or subroutines, and we attach a sequencing for them. We attach a sequence saying that functionality A will be executed, inside A, B, C, D might be executed, and something similar to writing procedures in a language C or Fortran or Pascal. But this way of decomposition was more in favor of procedural languages. Now let us go a little more deep into these two ways of decomposition. Let us first consider the algorithmic decomposition. About our example, if we see the radar and the gun, these two things were working together, and suppose for this small fragment of a functionality, we want to do the decomposition, because finally we are going to develop this system, means we need to do the decomposition. Now this way, in the algorithmic decomposition, what we are splitting, the unit of splitting is going to be a functionality. So typically if you see, consider this as a pseudocode, not necessarily this code might get compiled into any language, it will not in fact. But this is a kind of a pseudocode, just for the explanation purpose. So there will be some functionality called as a main. From main the start will be called. Within the start there will be few functionalities will be called. Now there will be some functionalities which will be elaborated at the separate point as a functions, procedures, subroutines, or the operations. And this way the total functionality is split. But here we are not talking about anything like the object, its responsibility, its data. In fact, whatever data is required for this system might be stored somewhere else as a global data. Now global data has got its own problems which people who have worked in the procedural world, they will understand. Because global data is everyone's data, and everyone's data means no one's data. And global data being used by all such functionalities was really a major problem in the algorithmic world. In algorithmic decomposition, we consider about the functional steps in overall process. The sequence is also embedded inside it, because one functionality is called from other functionality, and the sequence can be found out by how they are being called from each other. Necessarily, this way of decomposition used to give a picture of what is happening and in which sequence it is happening. This was the way algorithmic decomposition worked. If we consider a same system was to be decomposed into object-oriented world, then how we could do it? Here the objects are considered as autonomous agents, as the way we talked about it. So being autonomous agents, the agents, these objects, for example the operator, radar and gun, as the major objects which were taking part in the messaging each other and fulfilling the complete functionality. Radar itself being an object, radar had its own objects inside it. For example, it might be a surveillance antenna, the tracking antenna, the screen, auto level, then the power supply and whatnot, many other things. Gun also had its own set of the objects inside it, and that is nothing but a data which is required for this outer layer object for working its own functionality. Now every object had the functionality along with it as a capsule, which we have seen. For example, if you see the surveillance antenna, its task was keep searching the target. Once it finds the target, it is going to send a message to other object, that is a tracking antenna. Now tracking antenna's functionality is mentioned here, that is the lock on to target and send position to whom, to gun. And this is the way actually the decomposition happened. Right now you will observe that we are not using any specific kind of a notation here. It's a free form diagram. But problem is the free form diagram being not very accurate notation can convey different meanings to different readers. For example, what this arrow is meaning. Does this arrow say that this object is going to call method of this object, or this object is going to execute functionality after this object? So is it really a positional indicator, or is it really a time indicator? Now, by understanding the ways of decomposition of a system, we are now ready to see the notation in which we are going to document our decomposed objects, which are going to be input for the further system analysis as well as the final design stage.